In this tutorial, you will learn about the concept of limiting reagents and excess reagents. Some things you should already know before watching this tutorial are the following: the difference between coefficients and subscripts in a chemical equation, how to balance a chemical reaction, and the concept of the mole. Balanced chemical equations tell us the relative number of reagent particles used and the number of product particles formed. For example, 2 H2 molecules plus 1 O2 molecule yields 2 H2O molecules. However, reagents are not always available in these perfect ratios. This often causes a reaction to have a limiting reagent and an excess reagent. To better understand this concept, let's use the analogy of making s'mores. To make a s'more, one must have 2 graham crackers, 1 chocolate bar, and 1 marshmallow. A balanced equation for making a s'more would be 2 graham crackers plus 1 chocolate bar plus 1 marshmallow makes 1 s'more. If we have 8 graham crackers, 5 chocolate bars, and 6 marshmallows, how many s'mores can we make? Take a moment to pause the tutorial to try to answer this question. Let's combine our ingredients to see how many s'mores we make. 2 graham crackers plus 1 chocolate bar plus 1 marshmallow makes 1 s'more. We have run out of graham crackers, so we cannot make any more s'mores. Because the graham crackers limited us to only making 4 s'mores, the graham cracker is a limiting reagent. We still have chocolate bars and marshmallows left over. These are the excess reagents. Based on this observation, let's define a limiting reagent and an excess reagent. A limiting reagent can be defined as a reagent in a chemical reaction that limits the amount of product that can form. When we made s'mores, the graham cracker limited us to only making 4 s'mores. The reaction will stop when all of the limiting reagent is consumed. Therefore, only 4 s'mores could be made. At the end of the reaction, the limiting reagent will be completely used up. In the s'mores, our limiting reagent, the graham crackers, were completely used to make s'mores. The other reagents, such as the chocolate bars and the marshmallows, were not completely consumed. These are the excess reagents. Because not all of the excess reagents were made into products, they could not tell us how much product we would make. When we ran out of graham crackers to make s'mores, there were 2 marshmallows and 1 chocolate bar remaining. The excess reagent will be left over when the reaction is finished because the limiting reagent will be completely used up. Before we made these s'mores, we had more graham crackers than any other ingredient, and we had the least amount of chocolate bars. It is a common mistake to assume the chocolate bar is the limiting reagent because we started with the least amount of it. However, the balanced chemical equation told us we needed more graham crackers than the other reagents to make 1 s'more. Therefore, the graham cracker limited us to only making 4 s'mores. As you can see, the use of the balanced chemical equation is very important in solving limiting reagent problems. It is also a common mistake to assume the limiting reagent is the reagent with the smallest coefficient in the balanced chemical equation. The graham cracker was the limiting reagent even though it had the biggest coefficient in the equation. It is important to consider both the measured amount of reagents and the balanced chemical equation. Now let's consider a chemical reaction between gaseous nitrogen monoxide and oxygen gas to form nitrogen dioxide. The balanced chemical equation for this reaction is 2NO plus O2 yields 2NO2. If we have 7 particles of NO and 3 particles of O2, how many particles of NO2 can be formed? Take a moment to pause the video and draw what the product mixture will look like. Let's see how many particles of NO2 we can make. In a chemical reaction, the bonds of the reagents break and the atoms rearrange to form new bonds with other reagent atoms. To form the reaction mixture, we must break the bonds in nitrogen monoxide and the bonds in oxygen to form the new bonds in nitrogen dioxide. Because we ran out of oxygen molecules to form another NO2 molecule, oxygen is our limiting reagent. It limited us to forming only 6 molecules of NO2. The reagent left over is NO. Therefore, it is the excess reagent. Now that we have examined limiting reagent at a particulate level, let's see if you can identify the limiting reagent and the excess reagent on the macroscopic level. Solid zinc and aqueous hydrochloric acid are combined in a beaker. Bubbles form as hydrogen gas is produced. You observe the beaker after the bubbles stop forming to find solid at the bottom of the beaker. Pause the video to determine the limiting reagent. How do you know that it is the limiting reagent? Because we still see the solid zinc when the bubbles stop forming, we know that the solid zinc was in excess. That means we must have used up all of the dissolved HCl particles to make the hydrogen gas bubbles. Because the HCl was completely used up and limited how much hydrogen gas formed, HCl is our limiting reagent.